Okay, so we go to the test of between subjects effects. We look at the line that begins roll, and the significance value is 0.332. So these means are not significantly different. So we've done our research. We wanted to see if workers' well-being was different depending on the type of role that they hold, and we find that they're not even close to being significant. So we go home and kick the cat or something like that. Prasanthi, how many marks for the qualitative assignment? It's equally weighted with the quant assignment, so they're both worth 50% of the module mark. Yeah, so we've got no significant difference between our groups. So, well, that's a bit of a blow. We'll not be rich and famous this week. But we go back to our data set. And we go, well, I'll tell you what, well-being might not just be a function of the role that you're undertaking, but it might also be associated with the number of hours a week you work. So perhaps if we can explain some of the well-being by the amount of time that people are spending at work, that might be a useful covariate, because there's no particular reason why we would perhaps expect the people in the different roles to necessarily be working different hours a week. There may be, but it's not. But we would perhaps think that somebody who's spending all the time at work might feel that they have got less self-rated well-being because all they're doing is working. And so those two things may well be related to one another. So that might be a good covariate for us to use. Well, if we're going to use this as a covariate, then what we've got to do is, the first thing that we've got to do is check this homogeneity of regression assumption. And I said you can do this visually or you can do it statistically. Visually is by getting graphs up. Our good old friend, the scatter plot. Is there anything a scatter plot can't tell us? Probably, but never mind. So we'll get a simple scatter, and we'll put our self-rated well-being in the y-axis and our covariate, our weekly work hours, in the x-axis. And where it says set markers by, we will put job role in set markers by. And then we click on OK. And we get our scatter plot, and you can see that there's different coloured dots on the scatter plot, and the different coloured dots relate to whether people are unskilled, skilled, middle management, or senior management. And if I double click on there, it opens the chart editor box. And click on elements. I can now fit line at subgroups, which will give us a line of best fit for each of the 4 subgroups. I'll remove that and apply. And you can do it SPSS, close, and then close that. Now, what is interesting about this, and I didn't notice this until earlier today, is that 2 of these groups must have exactly the same lines of best fit, because there's only 3 lines that appear on there, which is quite interesting in itself. Because we asked for them, and it's indicated that there's 4 lines there, but you can only see 3. So 2 of them must have the same line of best fit. They don't particularly look to do, but it's the only reason why I can think that it is like that. The important thing is, what we're looking for here is, are all these lines going in the same direction? In an ideal world, we want them to be parallel with one another. well, the world isn't ideal and you never really get to be parallel with one another. But importantly, they are all going from top left to bottom right. They're all going in the same direction. You would be really concerned if one of the lines of best fit was going in this direction, showing that the relationship for one group between weekly work hours and self-rated well-being was just completely different to all the rest. If that was the case, you'd seriously have to abandon the analysis of covariance. But they're not. They all look all right. Okay, I said you can also test it statistically. So, analyse general linear model, univariate. We now take our covariate, weekly work hours, and we put it in the covariance box. Seems a very sensible place to put a covariate. But the next thing that we do is something quite unusual. We click on Model at the top right. And the default is full factorial, but we have to build a custom model. And what we do is we take our independent variable role and send that over. We take work hours and send that over. But the thing we're really interested in is the interaction term between these two. We send that over and you see you've got role star work hours. And that's the interaction between the independent variable and the covariate. We then click on Continue. Okay. The only thing we're interested in here is this line in the tester between subjects effects, the one that begins role star work hours. We are only interested in seeing whether that is significant. And it's nothing like significant. It's far away from significance as you could wish it to be. Which is good, which is exactly what we want. It means that effectively those lines in the scatter plot are all the same as one another. If this is significant, however, then we have to again abandon the analysis of covariance because it means that the relationship between our covariate and dependent variable are different for the different conditions, and that's how we test that. So, we can be happy with the fact that what we've got is no violation of the homogeneity of regression assumption. So we can do the analysis of covariance now, so we have to go back to Analyse General Linear Model Univariate. We have to go back into the model, and rather than our custom model, we are now using a full factorial model. So we go back to that, click on Continue. Then in, let's see, Options, I've got descriptive statistics. I'm also going to select display means for in the estimated marginal means, and you'll see why in a moment. And compare main effects. Well, in fact, I'll tell you why now. It's because we've got 4 different roles, and one thing that we can't do in the analysis of covariance is we can't do post hoc comparisons like we can for the one-way analysis of variance. And so if we want to find out which group's significantly different from which, you have to go through this estimated marginal means route to then compare main effects and select a confidence interval adjustment. We always use Bonferroni. Then we click on Continue and on OK. And first things to look at, if we look at the descriptive statistics here, 27.9, 30.4, 31.3, 32.24, and go back to when we did it before, the means, the descriptive statistics are exactly the same. And, well, they would be because it's just the same data. Well, if we think about where we had a non-significant difference the first time we did it, oh, it's right up here. 0.332 the significance value was. The mean squares for the roll was 66.777. and the mean square error was 57.679. When we come down here, all of these things have now changed because we have introduced this covariate. We've introduced this covariate, which adds to the variance in the study. Importantly, the significance here of roll has now gone down from 0.332, was it, or whatever it was above. It is now significant. And why is it significant? It's because we've added in work hours, our covariate. And if you look, the amount of variance explained by the covariate is huge, 541.876. It's explaining lots of variance, highly significant, and because it's done that, it's improved the significance of roll. And so now there is a significant difference between the groups. So if we'd done our study and hadn't asked our participants how many hours they worked a week on average, we wouldn't have been able to do this analysis of covariance, and we'd have ended up with a non-significant result. But by asking them that and thinking, well, it might be related to well-being, it's added in, it is significant, which means it was worth including in the analysis, but more importantly, it has improved the significance of job role. One other thing happens, and that is you get a slight change to the mean values. It adjusts the mean values a little bit. So we had 27.9, 30.4, 31.3, 32.24. In the estimated marginal means, these are 26.7, 29.9, 32.7, 32.6. Why has it done this? Well, what it does here is it effectively takes the average number of hours worked across everybody, which in this case is 41.7. And then it says, based on the relationship between work hours and well-being, what would the mean for well-being of the four groups be if they all worked exactly the same hours? And so it adjusts these means slightly based on that to equate them all for differences in their working patterns. So they're not huge adjustments. We've gone 27.9 down to 26.7, so that's gone down 1, and middle management's gone up a bit, skilled's gone down marginally. We could then go and have a look at where the differences exist in the pairwise comparisons, and we can see that the unskilled workers are significantly, let's see, they're not quite significantly different with the pairwise comparison that we've got on there. Unfortunately, 0.071. This is always problematic with the Bonferroni corrections, is that they're quite conservative, so it's not quite significant. Not quite significant with unskilled and senior management. But what you can see is that the effective difference that we've got by adding in the covariate is overall there is a significant difference between them, and effectively the unskilled has got the lowest score and the middle management and senior management have got the highest scores. But unfortunately the Bonferroni corrected comparisons are still not quite significant. Bit of a blow. Should have checked that earlier. Would have been nice if they were significant, but never mind. The important thing is the difference that you get here by adding in the covariate. It increases the power of the ANOVA, so that with the same data we've gone from a nowhere near significant difference to a significant difference. Okay. And that is the analysis of covariance. Really, really useful technique, and something that's always worth bearing in mind when you're collecting your data, because if you can improve the power of your analyses, you're going in the right direction. Okay. So I think it's 6 o'clock. I think that's a good place to stop today with this first trial into recording through your Teams. Hussein, yes, if you randomly invite 1,000 employees in the UK to participate, this study would be 73 rounds. It wouldn't be fully representative, Hussein, of the overall population, but it would be as representative as you got from the people in the study. It depends. If you are really interested in gender differences, then you would try like mad to get a much closer map between your males and females. If gender differences is something that you're interested in. If gender differences isn't something you're particularly interested in, it wouldn't be something that really worried you. So the deadline for the assignment 1 would be the 20th of September. It's gone from the 13th to the 20th, but this is a movable feast at the moment, Ekram. Well, it will be as random as you can hopefully get it to be, Hussein. That life isn't perfect, I suppose, is the important thing. Is that you get what you get, but if you are interested in a particular aspect, you can target your population to get what you want. If you're interested in gender differences, then you could randomly sample females until you got as many as you got males. If you didn't have as many, you could just randomly sample more so that you could get more of them. If they're not taking up the offer. If you have a question in between seminars, you can probably still chat in this particular meeting, even later, I think. Prasanthi, you don't do an over and uncover in all cases only. So, if you've got a covariate, you would go straight in and do an uncover. If you haven't got a covariate, then you wouldn't. It's only if you have a covariate that you would consider using the uncover. And a lot of people gather information on things that they think might be useful covariates to include in analyses. And then if they don't make a useful contribution, you can drop them out again of the analysis. Are you able to access the work for weeks 9 and 10? Unfortunately not, Alex. I can't access it. So I'm having to write new stuff for presenting to you for the next couple of weeks so that I can keep you going. My Northumbria email is currently working. I'm using it through Office 365 and it is currently working. So you can email me at my uni email address, and at the moment it's still working. Okay, yeah. So let's try and just keep everything going, and I will